Hi everyone, Tina here, and today I'd like to talk about factorising and solving quadratics. I'd also like to talk about a special case of factorising called difference of two squares, or DOTS for short. You'll need to know about these ideas for both the Foundation and Higher GCSE courses. I'll run through the key ideas with some examples along the way. So let's start by thinking about what is a quadratic expression or equation. They usually look like this: ax squared plus bx plus c, where a, b and c are numbers. More generally though, a quadratic expression is an expression where the highest power of x is x squared, and a quadratic equation is a quadratic expression with an equal symbol, and it's usually equal to 0. The word quadratic actually comes from the word quadratum, which is Latin for square. And that's because it's all to do with x squared. Now we know what quadratics are, let's talk about factorising them. Factorising in algebra is the opposite process to expanding brackets. So if a question says you need to factorise, that means you need to put brackets into the expression. Now for quadratic expressions, when you factorise, you're going to have two sets of brackets. To work out what goes in them, there are lots of different methods out there, but I'm going to show you my favourite. First of all, I always start by putting an x and an x, because that's how we get our x squared if we were to expand it again. Then, to work out what else goes in the brackets, we need to think about two numbers that multiply to give plus 6, but at the same time add to give 7. So we want two numbers that multiply to give plus 6, but also add to give plus 7, and that works out to be plus 6 and plus 1. Once you know this, you can put those numbers inside your brackets with the x's, and you're done. Now, because factorising is the opposite of expanding brackets, we can actually check our answer by expanding the brackets out again. So you can use FOIL or something similar to expand these brackets out, and that would be x squared plus x plus 6x plus 6. If we were to tidy this up, that's going to give us x squared plus 7x plus 6. So we know we've done it right. This also helps us to see why this method works, because you know you need your two numbers to multiply to give you this number on the end, but also you want your x terms to add to give you 7. Let's look at the next example. So for this one, we want to think of two numbers that multiply to give negative 18, but add to give negative 3. Now, sometimes it might take you more than one try to find these numbers. So you might think, okay, well, plus 9 times minus 2 gives minus 18, but those don't add to give negative 3, so that can't work. Minus 9 plus 2 also doesn't add to give minus 3, so that's not going to work. And then you can think about maybe minus 6 plus 3. Those two times to give negative 18, but also add to give negative 3. So that's what we want. Once we've found our two numbers, we can write our brackets, n and n in this case, and then minus 6 plus 3. In either order is fine. Last example on this page, two numbers that multiply to give plus 36, but add to give negative 13. In this case, we actually want negative 9 and negative 4, because negative 9 times negative 4 makes plus 36, but negative 9 plus minus 4 also makes minus 13. So the answer for this one is going to be x minus 9, x minus 4. And remember, if you're in an exam, you can always check your answers by expanding the brackets again. Let's talk about solving quadratic equations now. So in algebra, that word solve means you need to find whatever letter it is that you're working with. In this case, x to begin with. To do this for a quadratic equation, you can factorise it first, just like we were doing before, and then solve it. Before you do your factorising, you need to make sure that the quadratic equation is equal to 0 first. That is really important. Now we can factorise. So for this one, we need two numbers that multiply to give plus 10, but also add to give negative 7. So that's going to be negative 5 times negative 2, also adds to give negative 7. We put those numbers inside our brackets with x as well, make it equal to 0 this time. Now here comes the solving bit. What we can see here is that something times something else is equal to 0. Now the only way for that to be true is if either one of these brackets themselves was actually equal to 0. Because if you think about it, 0 times anything is always 0. We can then solve each of those brackets being equal to 0 separately. So for the first one, if we say x minus 5 is equal to 0, that would mean x would have to be 5. Or if x minus 2 is equal to 0, that would mean x would have to be 2. And those are our final answers for x. Let's do another example. So solve a squared minus a minus 56 is equal to 0. Good that it's already equal to 0, so we don't need to do anything there. Now let's think of our two numbers that multiply to give negative 56, but also add to give negative 1 in this case. Remember, if there's no number in front of the letter, that's like an invisible 1 in algebra. So thinking about what times is to make negative 56, one of the options is minus 8 plus 7, and those two numbers also add to give negative 1, so that's what we want. Let's factorize. So a minus 8, a plus 7 equals 0. Once again, we have something times something equals 0. The only way that's going to be true is if either one of those brackets are actually 0 themselves. So you can write it out or you can just think about it. What would a have to be? A would have to be positive 8 or a would have to be negative 7 in order for those brackets to be equal to 0. Now let's talk about a special case of factorising called difference of two squares, or DOTS for short. You can identify DOTS when an expression looks like this. So difference of means we have a subtract. And then we need two square numbers. So in this case, x squared and 100. Those would be our two squares. Hence the name, difference of two squares. The trick for factorising with dots is this. You open up your two brackets as usual. And in this case, it's going to be x, and then 10 and 10. Know this because x is the square root of x squared and 10 is the square root of 100. You then put 1 plus and 1 minus inside the brackets in either order, it's up to you, and that is finished. Now the reason this trick works is because if you expand the brackets out again, you'll see what happens. Expand this out, we're going to get x squared minus 10x plus 10x minus 100. So the most important thing is these two terms cancel each other out. So in the end, you don't have any terms that just have x in them. And that's why you need the brackets to look the same as each other, but with 1 plus and 1 minus, so that those two middle terms will cancel each other out. For the next one, factorise b squared minus 81. That's dots again. So if we do the trick, open up the two brackets. In this case, we'll have a b and a b, and then square root of 81 is 9, so we can put 9 and 9, 1 plus, 1 minus, and we're done. Slightly harder examples on this page, but still dots. We're going to open up our two brackets, and then the square root of 9p squared is actually 3p, so we'll put that there and there. And the square root of 16q squared is 4q. 1 plus, 1 minus, finished. Now the last example is a bit sneaky. You should always check to see if you can factorise into a single bracket first. And in this case, we actually can, because 25 can go into both 25 and 100. So you can pull 25 outside of a single bracket first and make it x squared minus 4y squared. And then you actually have a dots here. So in terms of a final answer, we're going to have 25 on the outside. Then we're going to open up our two brackets and do the trick here. So x and x, 2y, 2y, 1 plus, 1 minus. And that would be the final answer there. So just watch out for something like this. See if you can factorise with a single bracket first. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And do share this with anyone else who you think might find it helpful. Thanks and see you next time.